You can use worked examples in a few ways, so I'm going to show you what I've done. So you can think about some work that you have in front of you that's correct work and talk through it and analyze it. This is going to feel very similar to direct instruction. However, you're going to be more focusing on calling out the conceptual ideas and just modeling how you analyze work, because in the future you could have students do the same thing. You can give them work and have them analyze it as well, and this will help you assess what your students know and how well they can explain their thinking. So let me show you what this can look like. So there's a sector that has a central angle of 170 degrees and a radius of 12 centimeters. So we've got this diagram, picture of what's going on there. We have the 170 degrees and that central angle and the 12 centimeters. We need to find the area of the sector. So I want to find this area right here. And the first thing that I see on this work is there's an A with pi times 12 squared. And I do know that this A does stand for area. However, it's not the area of this sector. This is the same as pi r squared, which is the formula for the area of any circle. And so what's really happening here is this person has found the area of the entire circle. So let's put that here. So the whole circle has an area of 144 pi centimeters squared. Then here we've got some sort of fraction and some algebra going on. We're going to pause on thinking about what this 144 on the top is here and just look at those two fractions. That 170 out of 360 is using that degree of the 170 for that central angle, and 360 we know is the degrees of an entire circle. And then we've set this equal to some sort of value, something x, out of 144 pi, which was, remember, the area of that entire circle. And so why do we set up these fractions? Well, 170 out of 360 is giving us like just a fraction of a circle. So rather than saying like I want half of the circle or I want a quarter of the circle, I can actually say I want 170 3/60ths of the circle. So we really only want this many degrees out of the entire circle. So that's the fraction of what we want. It's like saying we want half of it, we want a fourth of it, we want 170 3/60ths of it. And we are going to say that is going to be equivalent to some portion, some area out of the entire area. So this x here is the area of the sector. So that's going to be this area out of the whole area. That proportion should be the same as the proportion of just that degree out of the whole degrees. So once you've got those two equivalent fractions, or fractions that you want to be equivalent, we can go ahead and solve and find out what that x is. And so you'll notice here there's a 144 pi multiplied on both sides because they're trying to cancel this out here and get the x alone. So we can just solve and say, what does that equal? So as I multiply 144 pi on both sides, we've canceled it out here, and you can see that there's just some, it's basically just simplifying of fractions going on here. I can tell that the 170 out of 360 became a 17 out of 36, just kind of divided both of those by 10. I can tell there's some other dividing going on here, so I think that the 36 and 144, they canceled out both of those. You can divide that by 12 and you can divide that by 12, so we got a 12 and a 3. And then 12 divided by 3 is 4. So all this, it's a little bit funky looking, and it might look like that on your own paper as well, but it's all just simplifying that fraction down. And so then the 68, we could double check it on a calculator too, but 4 times 17 is 68. And then there's still that little pi guy right there. So we've got 68 pi, which when you multiply those together, you get 213.6 centimeters squared. You can also use incorrect work and either use it to help focus on what common misconceptions might be and help keep students from making those. You can also use it to help assess student learning and have them critique and analyze somebody's work. So here's an example of something I gave on an online quiz. So I gave this work and asked the students what went wrong in the problem and how they could fix it. So here's an example of what a student submitted as their answer. So she's noticing that the mistake is that they used the wrong trigonometric ratio to find x. The reason is that 20 is not the adjacent side, so she's looking here and recognizing, opposite, adjacent, and hypotenuse, and so, but it's the hypotenuse. So the correct trigonometric ratio to use in this problem is sine. So just from being able to read that, I can tell that she's found the mistake and she understands why it's incorrect. And it's more than just like, do a problem, here's the answer. She also then continued to say, I showed my work the correct way below, and just kind of did those steps again herself. So it's more going through the problem and not just doing something and getting an answer, but thinking through it, understanding the concepts, and being able to talk about it as well.